addition and subtraction. Addition and subtraction of vectors. Now, let us consider a scenario where we have two vectors as sides of a parallelogram, right? This concept is for addition. So let us consider one vector like this. So this is, say, vector B, and I have another vector A. So this is A vector, B vector, right? Originating from a point, right? Let's say this is a reference point O, right? If we have two vectors, and let us assume that there is an angle between the vectors denoted by theta. Theta is the angle between vector A and vector B. If this is the case, we can find the answer, that is the sum of the two vectors A and B can be represented by the diagonal of the parallelogram. This is what is the rule. So let us try to draw the result first. Result is starting from the same point as that of A and B, and it will extend all the way through the diagonal. So this is the resultant R, which is the addition A plus B. Now how to measure this R? We can measure this R with respect to A or B. Okay, so with respect to A, let us assume that it is going to make an angle alpha, and with respect to B, it's going to make a different angle called beta, right? Alpha is the angle made by the resultant with respect to vector A, whereas beta is the angle made by the vector B with respect to so vector B and R. Between vector B and resultant R, we have an angle beta. So the theta is the total angle between vector A and vector B. So these are the notations. Now how to calculate? So the calculation is pretty simple and pretty straightforward. So using this diagram, we can represent R, which is A plus B. Okay, so R, which is equal to the sum of vector A and vector B. So this can be calculated as follows. This is A square plus B square plus 2 times vector A into vector B into cos theta under root. So this is okay. Resultant is represented using this equation. First point. So if theta is the angle between the vector A and vector B, as shown in this diagram, we need to find the position of this resultant with respect to A or with respect to B. That means I am supposed to find the alpha and beta. Okay, so to find the angles, we use this equation. The tan alpha is equal to, this is B sine theta whole divided by A plus B cos theta. Theta is known to us, so we can apply this rule. This implies I can find alpha as a tan inverse ratio. This is tan inverse of, so this is B sine theta whole divided by, this is A plus B cos theta. Important equation. So alpha find ಮಾಡಲಿಕ್ಕೆ ಇದನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅದೇ ತರ we can use another tan ratio, that is tan of the second angle beta can also be calculated. So using this equation, it is A sine theta whole divided by, this is B plus A cos theta. So this implies I can find beta directly by applying inverse tan to the other side. So that is A sine theta divided by this is b plus a cos theta. Okay, so for addition, so this whole rule is applicable for addition only. Whenever I am trying to do a plus b, this is going to work. Okay, ಆಯ್ತಮ್ಮ note ಮಾಡಿದ್ಯಾ? Doubt ಇದೆಯಾ ಏನಾದರೂ? Okay, let's go. Then now we'll go for the subtraction part. A minus b, right? So in this case, we will consider the same two vectors but on the opposite side. That means, so let's draw the parallelogram in this way. So out of which we have a as it is. A na ade tara baritini. This was the original a. But you see, if you look at the previous diagram, we had the b over here. B itara iತ್ತು. Okay, this was b, right? But we know that from the vector representation, any vector which is opposite of a vector, if this is vector b, equal and opposite vector is called as minus b, right? So I use this concept. You see, b from this point o, I have a vector going upwards, which is b. Equal and opposite vector should be minus b, right? So now I'll come to the concept of subtraction. Subtraction says, if at all, let's write the subtraction now. So subtraction result, let me call it as s. So let s is equal to vector a minus vector b. This is nothing but vector a plus minus b, right? It's valid because minus ಅನ್ನು ನಾನು ಬ್ರಾಕೆಟ್ ಒಳಗಡೆ ಹಾಕೊಂಡ್ರೆ ಹೊರಗಡೆ ಪ್ಲಸ್ ಉಳಿಯುತ್ತೆ, ಸರಿ ಅಲ್ವಾ? So the plus, I have to add a and minus b. That's my resultant, which is s. So a ಮತ್ತೆ b add ಮಾಡಿದ್ರೆ ನನಗೆ ರಿಸಲ್ಟ್ ಹೀಗೆ ಬಂತು. This was r. Okay, but now you see what I'm trying to do. I'm going to add a and minus b. So when you add a and minus b, where should be the result? So the result is expected along this diagonal. So this is the result. Okay, so this will be the s, which is the subtraction. One and same, right? ನಾನು ಮುಂಚೆ ಬರ್ದಿರೋ ತರನೇ ಇದನ್ನ ಕೂಡ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು, but you see the difference now. So if you want to calculate this s, then the equation is pretty much similar, but there is a difference because it is vector, it is a square plus b square, it is minus 2ab cos theta. Okay, so this is just because of the fact that b is a reverse in direction. So I have to write it in this way. So there is a square root coming into picture. So let me also mark the required angles now. So there is one thing. Let's say this angle. The total angle is now 180 minus theta. Previously it was theta. Now this angle is 180 minus theta. Are you okay? Why it is 180 minus theta? You see, this total angle between b and minus b is 180. Okay, that's the first thing. And the second point is this between a and b, it is theta. So ಉಳಿದಿರೋದು ಎಷ್ಟಾಯಿತು? On the other side, it is 180 minus theta. So we are simply using this concept to calculate the angle between vector a and vector minus b vector. So we just use this. So the angle between vector a and vector minus b is 180 minus theta. So everything is applicable over there. And when we write root of a square plus b square plus 2ab into 180 minus cos of 180 minus theta. Cos of 180 minus theta is minus cos theta. So you can see that illondu minus bandu bidutte. So this sign change is important when you calculate the difference. That is for s. And let's go ahead. How to calculate the alpha and beta? Let me mark alpha and beta first. So according to the current convention, the alpha is the angle made by vector A and S. So A ಮತ್ತೆ S ಮಧ್ಯದಲ್ಲಿ ಇರೋ angle ಅನ್ನು ನಾನು alpha ಅಂತ ಕರಿತೀನಿ. Between minus B and S, this angle is what we are going to call beta. So alpha and beta are the angles, right, which are made by the resultant vector S with respect to A and B vectors respectively, right? Okay, so let's use this itself to calculate the alpha and beta. So very similar equations are going to come. So in subtraction, tan alpha is given by, this is B sine theta whole divided by, this is A minus B cos theta. So sign change agide, that's the difference. So this implies alpha can be calculated as, this is B sine theta whole divided by, this is A minus B cos theta. Oh, my mistake. There has to be a tan inverse. So this is tan inverse of. Similarly, we can calculate the beta as well. So tan beta can be calculated by using this equation. This is A sine theta whole divided by, this is B minus A cos theta. Ellalli cos ideo alli sign change adu. Okay, only that's the idea now. Previously this was positive, now it is negative. Okay, so this means beta is equal to inverse tan ratio of A sine theta whole divided by, this is B minus A cos theta. Okay, now okay, let's calculate, let's go for a problem, right? Problem number 1, find vector A plus vector B, vector A minus vector B. Given diagram, this is vector A and it has a magnitude of 4 units, and there is another vector which is this. Okay, this is vector B, and this measures 3 units, and the angle between them is 60 degrees. Okay, all right, so first A plus B, let's say vector R is equal to vector A plus vector B. So this has to be equal to under root vector A square plus B square plus 2AB cos theta. So this is nothing but, this is 4 square plus 3 square plus 2 into 4 into 3 into cos 60. Okay, root 37 units. That is vector R, which is the addition, result of addition. Okay, and when we say R, you have to find either alpha or beta. Okay, one of them is expected. So let's calculate alpha now. So tan alpha is equal to B sine theta divided by A plus B cos theta. So let us substitute. This implies, okay, let's calculate alpha itself, right? So this implies alpha is equal to tan inverse of, so B, that is 3 sine of 60 degree whole divided by, this is A, that is 4 plus 3 cos 60. Okay. All right, find the alpha now. So this answer is actually, verify once, tan inverse of 0.472. Have to calculate the tan inverse of for this value. Tan inverse Mardaga, I think we get a 25 degrees. 25.3 degrees is the answer for alpha. Okay, that is the sum. Let's go to the difference. So let S is equal to vector A minus vector B. So according to the equation, this is A square plus B square minus 2 times AB cos theta under root. So this has to be 4 square 16 plus 9 minus 2 into 4 into 3 times cos 60 under root. Okay, calculate the value now. Root of 13 units. So let us calculate the angle between them once again. Again, you can use the tan alpha. So according to the subtraction rule, tan alpha is given by B sine theta whole divided by, this is A minus B cos theta. So substituting this value to find alpha. So alpha has to be tan inverse of 3 sine 60 degrees divided by, this is 4 minus 3 cos 60 degrees. So tan inverse of 1.039, that comes to be approximately 46.1 degrees. Okay, so this angle is measured, if 46.1 degrees is measured with respect to vector A. Okay, right, fine. So similarly, we can find the beta directly, because angle between them is given as 60 degrees, right? We can actually subtract this to get the actual answer. Okay, so fine. Okay, let's move on. Next, we have what is called as the law of polygon. Right, this is something like if I want to add several say vectors, right? So that is okay, let's give a statement. Statement says if a vector polygon be drawn, placing the tail end of each succeeding vector at the head preceding vector their resultant, then the resultant R is drawn from tail and first vector to the head of the last vector. This is a statement, but meaning is very straightforward. So let us assume that I want to calculate R is equal to sum of say 3 or 4 vectors. That is vector A plus vector B plus vector C plus vector D. All right. So one method is that you calculate A and B, call it as vector R1. To that vector R1, you add the next vector, that is C, right? So to get another vector R2, that R2 plus last vector D is your final vector. So this is the actual method to do that, but the law of polygon comes into picture at that time. So you can calculate the final result R directly, right, as follows. So let's assume that these are the 4 vectors which we were talking about, right? So let's say this is vector A, okay, and you place the next vector at the end of this. So this is vector B, okay, and place the next vector at the end. So this is vector C, okay, and place the next vector at the end of this vector. So this is vector D. So according to this, the statement, you have to place the vectors one after the other. So that's why this is vector A, this is vector B, this is the vector C, and final vector D. Now, according to this rule, the resultant can be directly drawn, right, from the last point of first vector to the right tail of the first vector to the head of the last vector. Simply draw that to get the result. So andre ಇಲ್ಲಿ start ಮಾಡ್ತೀನಿ. This is the tail of my first vector. This is the head of the last vector. So tail to head, draw directly, you get your resultant up. Right? This is called as the law of polygon, used to calculate the resultant of vectors when we add multiple vectors to it. Okay, then previously we considered one case to calculate the components of vector, but now we find the component of the vectors, but the angle between the two vectors, right, is not known, is completely different, right? So angle between the x and y axis is different. Previously it was 90°, but now it has to be a different case, right? So let's move on to the next topic. This is once again components of vectors. So, but in this case, just note that x and y axis are not mutually perpendicular. Okay, the meaning is straightforward. I'll just go back. So we have seen here, okay, in such case, you see the angle between x and y axis, it's actually 90°, properly 90°. They are perpendicular to each other. So now ಈಗಾಗಲೇ ನೋಡಿರೋ ಇದರಲ್ಲಿ x ಮತ್ತೆ y axis ಮಧ್ಯದಲ್ಲಿ 90 degrees ಇರುತ್ತೆ. Okay, so we know how to calculate the components of such vector. Phi ಅಂತ ಇದ್ರೆ this will be 5 cos 60, y component is 5 sin 60, like that. We know that. Okay, but now it's different. Now x and y axis are not perpendicular, right? That's why this is a different case. So what I mean is this. Let us draw the axis first. Let's say this is the x-axis. But you see, y-axis is not making 90-degree. Y-axis makes some different angle. So you see, this is the y-axis. Right? It's not necessary always that x and y-axis needs to be mutually perpendicular. You have some systems where the coordinates are not perpendicular. All right, fine. In such a situation, let us try to do some other slightly more analysis. Let me consider a vector now. Let us assume that this is my vector. So vector originates from this point and it goes all the way, originates from the same origin. It is like this. Let's assume. Okay, if this is vector r, some vector, and I still assume there is an angle alpha here, there is another angle beta. So total angle between x and y axis is alpha plus beta, total angle. Okay, let's make things a little bit simpler here. Let's do one thing. What we do, we try to draw a polygon over here. Okay, starting from this point. Okay, let's turn this way. Okay, now the components are very similar. This component is r along x-axis. This component is r along y-axis. Our intention is to calculate rx and ry. Okay, so from the basics of triangle, I can say that this will be the beta and this will be the alpha, right? Because two straight lines on the top and the bottom, its angle made by that line, the diagonal remains same. Okay, we have a law called law of triangles. Okay, this is specifically called as sine law of triangle. This has to be applied now to solve this. So sine law says that consider any triangle and consider the sides of the triangle. It is we use the law of sine to a triangle to relate the sides of a triangle to the angles of a triangle. Okay, fine. So let me make things clear now. So this means this is r and the angle opposite to r should be 180 minus alpha minus beta, because other angles are this, right? So opposite of alpha is ry. Okay, so this is ry, and the horizontal line is rx. Okay, rx is this is rx. So Fine. Now the sine law of triangle says this way. So I'll draw a general diagram and the general equation. So if you consider a triangle maybe like this, okay, let's consider a triangle, any triangle. So if I say this is A, let's give it in different way. So this side is A, this side is B, this side is C. So opposite of A, I'm going to call it as say alpha. Opposite of B, I'm going to call it as beta. Opposite of C, I'm going to call it as say gamma. So the law of triangle says you take A, one of the side, divided by the sine of the opposite side. Opposite side is alpha. A by sine alpha. Idu A tagondre E angle agutte. So A by sine alpha should be equal to, this is B divided by sine beta. So which is B is this. What is beta? Opposite side angle. All right. So that is equal to the C divided by sine gamma. So this is the fundamental rule we are going to use now to solve our above said problem. So this is the fundamental rule. Now let us apply this to the above equation, right? Above diagram, E diagram ge apply ಮಾಡ್ತೀನಿ. All right. So that means first let me write for R. For R, the opposite side angle is 180 minus alpha minus beta, right? So the rule becomes now, this implies R divided by, it should be sine of that angle. Angle is 180 minus alpha minus beta equal to, check any other in the sense it is Rx. Rx tagondre, what is the opposite of Rx? That is beta. Okay, so I am going to write that now. So this is Rx by sine of beta equals to the other side, that is Ry. This is sine of alpha. So we have one property here. Idana simplify madibirtini. So this implies the resultant R divided by, right, sine of 180 minus theta is same as theta. So sine of 180 minus one bracket to alpha plus beta. This is 1 and c. So this is what I get on the left hand side, equal to same thing on the right hand side. Idan innond sala simplify ಮಾಡಿ ಬರೆದು ಆಮೇಲೆ ಆನ್ಸರ್ ಬರುತ್ತೆ. So this implies R divided by sine of, we use one more property, that is sine of 180 minus theta is the same as sine theta. There is another property. Okay, we'll deal with this in mathematics later. But as of now, let's just remember sine of 180 minus theta. Theta estide a bari alpha plus beta. This is the theta. This is equal to, write the others as it is. Rx by sine beta equal to Ry by sine alpha. Okay. Now use this to calculate the actual component. Right? So this implies namge R ಗೊತ್ತಿದೆ, alpha plus beta kuda ಗೊತ್ತಿದೆ. If that is the case, you can calculate Rx using the following formula. Rx calculate ಮಾಡೋದಕ್ಕೆ ನಾನು ಇದು ಎರಡನ್ನ ಯೂಸ್ ಮಾಡ್ತೀನಿ. So Rx is equal to, right, take sine beta to the other side. So what is your answer now? So this means R into sine beta divided by, this is sine of plus beta. Okay, and if you want to calculate Ry, then use these two. Use. So in order to calculate Ry, I move sine alpha to the other side. Okay, so this also implies the y component is now, this is R sine alpha divided by sine of alpha plus beta. Right. So whenever x and y axis are not perpendicular to each other, then I am supposed to use these two equations to find the component of any given vector. What is the component along x-axis and what is the component along y-axis we can find. Okay. Okay, we'll use this when required. As of now, let's not solve any problem based on this. Okay. Then we have a specific vector coming up. This vector is called as a pointing vector or position vector, right? So position vector is related to uh, pointing out a vector, from origin to a given point P. Okay, so let's try to understand this. Let's consider a situation. So this is the x axis and say this is y axis, and let me consider a point P. Right, in order to reach this P, it's very clear that I have to move certain distance, say x along this axis and certain distance y along this axis. Let me make x naught and y. Okay, and also we know that we have the unit vectors along this is I cap, and unit vector along y axis is j cap for us. So if I try to connect the origin O to this point P, right, origin to any point P, right, in space, this means this vector, that is vector OP vector, is the position vector of point P in space. So because in order to reach the point P, you have to move x naught and y naught distances along this, right? So the position vector is the vector that connects origin to a given point P in space. So in this case, the position vector OP is nothing but, right, the x component of that point, that is x naught into I cap plus y naught into j cap. So this is true for any given point, right? If the point is 3 comma 4, right, what is the position vector? 3i plus 4j. Okay, so like that. The same thing holds good for a three-dimensional case where you get a k cap as well. If the point P is like, okay, let's go for a simple problem, right? The find the position vector of the point 3 minus 4 comma 8, right? So it's very simple, right? Simply write the coordinate and multiply that with I, j, k, etc. I cap, j cap, k cap, etc. All right. So position vector is OP. Anything you can write, just simply vector R baradu nadiyutte. Okay. Vector OP is 3 times I cap minus 4 times j cap plus 8 times k cap is the position vector. So position vector ಬರೆಯೋದಕ್ಕೆ ಏನು ಕಷ್ಟ ಇಲ್ಲ. Simply find out the coordinates and multiply respectively by I, j, k. Right? If it is not a three-dimensional case, you don't have to use the third coordinate. Z is not going to come into. Z will not be there. So no k cap. Okay. Right. Then the next concept is called as the displacement vector. This is displacement vector. All right. Let's say, okay, let us consider a different situation now. This is x-axis and the y-axis. Let us consider two vectors. Okay, two vectors are, the first vector is say vector A, and second vector is vector B. So this is vector A, this is vector B. So this is origin by default, and if at all I want to draw a new vector which is connecting the end of A to the end of B. Okay, if this is the case, say I'm going to call this vector as, maybe if I call this is A, this is point A, and this is point B, this is vector AB. Okay, and I'll slightly make modifications. I'll call this as this by different names, because we know through position vectors we can name them as, let's say this is OB vector, O to B, this is OA vector, right? So let's also denote something here. X is denoted as a point A is denoted by x1 comma y1 comma z1, or the coordinates. Okay, 2 3 4 2 8 minus 3 etc. Some coordinates are there. Similarly, B has its own coordinates, is x2 comma y2 comma z2. Okay, now so the displacement vector in this case, if at all you had a original vector OA and you have another vector OB, in the sense there was an object at A and this object moved to new location B. Okay, so A object to B ge move agide. In such case, how do you find out the path the object has taken to reach B from A is called as displacement vector. This is a displacement concept, right? The object has moved from A to B. Then it is straightforward. So the displacement vector AB can be calculated easily by using the position vectors. Final position is B, its position vector is OB minus OA. So how to write them? It is straightforward. You see OB vector baribeku antidre nange, it has to be x2 times I cap plus y2 times j cap plus z2 times k cap. This is what is OB vector, right? By using the concept of position vector, minus write the OA vector, that is x1 I cap plus x2 j cap, not x2, sorry, y1 into j cap, x1 I cap, y1 j cap plus z1 k cap. So I ಜೊತೆಗಿರೋದನ್ನ ನಾನು ಕ್ಲಬ್ ಮಾಡಿ ಬರಿಬಹುದು. So this means it is simply x2 minus x1 into I cap plus y2 minus y1 into j cap plus this is z2 minus z1 into k cap. So why it is so? It is because see ಈ ಟರ್ಮಲ್ಲಿ I ಕಾಮನ್ ತೆಗಿಬಹುದು. ಇದು ಎರಡರಲ್ಲಿ ನಾನು I ಅನ್ನ ಕಾಮನ್ ತೆಗಿಬಹುದು. When you take I common, x2 minus x1 remains, which I have written, right? Very similarly, you can see ಈ ಎರಡು ಟರ್ಮ್ ಅಲ್ಲಿ j ಕಾಮನ್ ಇದೆ. So take j common, what remains is y2 minus y1. And similarly, you have k common here. So take a k outside, you get z2 minus z1. So this is the this vector, right? AB can be calculated by using the position vectors of your destination minus its starting point. Starting point A position vector is OA. So I have to subtract OA from OB. That is, you perform OB minus OA to get the answer. All right. So this is the vector, and this is called as the position vector. Sorry, not position, displacement vector.